So we've just witnessed the power of this chart. This chart in front of you is going to tell you everything that you need to know about nomenclature in the carbonyl family. So up at the top we see carboxylic acid and the ester and the amide and the nitrile, and all of those were type 1. And now we're focused on type 2, and type 2 has two, and that's aldehyde and ketone. So we just talked about how to name an aldehyde, and then we brought in a little bit of mix. If it has an aldehyde group and an OH, if it has an aldehyde group and maybe another particular type of functional group, how do we handle this? So we've did a couple of those examples of what I would call a multiple functional group molecule. Now we need to move on. And what we need to move on with is this concept of what a ketone is supposed to be. Because we've not really talked about how to name a ketone, have we? And that's the second kind of functional group that's going to be introduced in this lecture module. So let's start with ketone, and let's just review. A ketone is a carbon double bond O that is flanked on each side with some type of carbon compound. It could be a carbon chain, it could be a carbon ring, but there is a carbon on either side, or really on both sides, okay? All right, so let's do an example. Let's do a quick example, a simple little example. C double bond O, and on this side is one carbon, and on this side is one carbon. So we have a methyl group over on the left and a methyl group over on the right. That is the simplest ketone that we could make. The reason is because if we get rid of one of those carbons and put something like a hydrogen on it, it's not really a ketone anymore, is it? No, that would be an aldehyde. If we get rid of one of those carbons and put something like an OH there, that C double bond O, OH, that's a carboxylic acid, folks. So in order for this to be a ketone, it really does have to be a carbon on both sides, and this is the simplest. So let's figure out how to name it. According to the IUPAC rules, what would be the name of this ketone? Okay, well, let's make IUPAC people happy, and this is how we do it. Number 1, you find the longest carbon chain. Okay, well, that's kind of a no big deal. I mean, this is kind of what we've been doing for everything, right? So the longest carbon chain, that includes the C double bond O, because we're going to name it as a ketone. So it has to include that group. All right, so 1 and a 2 and a 3. There's 3 carbons there in a row. So you would normally name this as a propane. Well, guess what I'm getting ready to do? You got it. Get rid of the E. Now, we're going to have to substitute the ending for the proper ketone ending. And the proper ketone ending is going to be an O and an N and an E. O-N-E. And the reason that they use O-N-E is because there's an O-N-E ending on the ketone. I told you they're not very creative. They kind of make this common sense kind of stuff. So hopefully that's okay with you. So we're going to call this propanone. And propanone, O-N-E, means that for sure this thing is a ketone because it ends in -one. Now, propanone doesn't necessarily have to have a number. And the reason is because if this double bond O was at the first carbon here, that's not really a ketone. That would have a hydrogen on one side, right? So we couldn't have a one spot. That would be silly. That's a different functional group. We can't really have a 3 spot because that's the same story as carbon number 1. And because of that, we can't have that to exist. So the only option here is for that double bond O to be on the center carbon. That is it, folks. That's the only possibility that we have. All right, now, with that said, if you want to put a number, that's perfectly okay with me. I don't care. You're not going to make IUPAC angry. So where would this double bond O be located? The ketone group. Okay, well, that's on the second carbon the way that we've numbered it. So this would be a 2-propanone, and that will be the IUPAC name of that compound. Now, the 2 was not required because, once more, there's only one possibility for that to be, and that is on that second carbon, and that's it. So the 2 is kind of there just to make you feel good. All right. Okay, so let's try another one. Let's do a C double bond O, and on this side we'll do a CH2 and a CH3, and on this side we'll do a CH2, a CH2, and a CH3. So how do we name it? Okay, no big deal. I mean, we've been using the same IUPAC rules over and over and over and over. So what we do is we find the longest carbon chain that includes the functional group. Okay, so 1, 2, 3, 4, 5, 6. There's 6 in total, which means that this is a hexane, the E, and then O-N-E. So hexanone is going to be the parent name of the compound. But in this case, we really do have to put a number. And that's because that C double bond O could be in multiple spots throughout the molecule. I mean, the C double bond O could be here, the C double bond O could be there, the C double bond O could be there, and in each case, we have a carbon to the left and to the right. So we do have some multiple possibilities that are here, and in this case, the number is a requirement. We cannot leave that off. All right, so where is that going to be located? Well, if we number closest to the end with the ketone, again, that's always an IUPAC rule, you number closest to the functional group. Well, that would be to the left. So 1, 2, 3, 4, 5, 6. And on carbon number 3, that is where I would see the one, the ketone. So 3-hexanone is going to be the IUPAC for that compound. All right, so there's how we IUPAC a ketone. Folks, it's no more difficult than anything else that we've done. It's just another modification of the ending. That is all that these have ever been, and here is a new ending for us to use. It's just a matter of keeping it organized. That's the only thing that we have to do. All right, now with that said, these are IUPAC names, right? This is an IUPAC 2-propanone. This is an IUPAC 3-hexanone. So there are common names that we could use as well, and let me show you how easy those are. So if we had to common name the compound, what I do is I find the C double bond O, and here is my C double bond O group, right there, C double bond O. So that C double bond O, I know in this molecule is a ketone functional group. So I write the word ketone because I'm getting ready to name a ketone. That takes care of that carbon double bond O. The ketone also lets me understand that there's a carbon group to the left and a carbon group to the right. Well, what carbon groups are there? Well, if you look at the structure, we have a 1-carbon group to the left and a 1-carbon group to the right. So what I do is I name those groups. What's the name of a 1-carbon chain? Methyl. Well, how many? I don't want to say methyl-methyl ketone. That's silly. There's 2 of them. They're exactly the same. So write down methyl once and then put di out in front. Do not write methyl-methyl ketone. I mean, if you did, I would give you credit. Okay, I'm a sucker for that kind of thing. I'll give you credit. I'm not going to deduct the points, but save yourself some time and save yourself some trouble. There's 2 methyl groups. They're both identical, so you put di in front, and that takes care of both. Dimethyl ketone. There you go, folks. That's how we basically go through and give it a common name. Now, this one in particular has something that we go by because it is pretty common. And it's kind of like water Water's called dihydrogen monoxide, right? I mean, that's kind of the IUPAC with it. But this one does come along with a weird little strange name. And, you know, go back and think about Chemistry 251 when we talked about our carbon, triple bonded carbon. And I said, hey, this is called ethine, but the common name here is acetylene. And you're looking at this and you're thinking, ene? Well, that's a double bond. I know, it's one of those names. It's one of those names that we've assigned very, very early on. It just stuck with the molecule, and we really haven't left it because we commonly use it. And this molecule is very similar. If you take a look at what is there, there's one carbon to the left and one carbon to the right. There's two carbons here. We know it's a ketone. There's two carbons that come along. Well, what's the common name for a two-carbon chain? If you go back and think about any of the carbonyls that we've done, you would tell me acete. All right, so A-C-E-T. And then add on the word "one" for ketone. Folks, that's the structure of acetone right there. So that fingernail polish remover that you scrub all over your little bitty toes and your little bitty fingertips, all of that acetone is a ketone, and that ketone is that structure right there. Now, it is one of the few that we do this with simply because it is a common solvent, it's a common reagent. We've used it for years and years and years. This is the name that was given to it very, very long ago, and it just stuck with it. You're not going to see us do this with any of the other ketones, really, as far as this kind of simplistic common name is concerned. All right? Now, let's look at our second example. Second example, if we wanted to common name it, we can do the same thing, right? So I'll take a look at the C double bond O, and that represents my ketone group. And I have a grouping over here and a grouping over there. They're pretty simplistic. I mean, I can look at these and say, oh, look, there's a two-carbon chain. That two-carbon chain is going to be called ethyl. And then, oh, well, there's a three-carbon chain, and that three-carbon chain is going to be called propyl. And it's just my job now to put them in alphabetical order. I mean, that's, again, one of the things that we've always done with IUPAC. So E comes before P, and that means that the common name here is going to be ethyl propyl ketone. See, folks, I told you, it's not very difficult. It's just learning them in the very beginning. The biggest problem is keeping them separated. That is the biggest problem here. All right, how do we keep all of these different functional groups and all of these different names separate from each other? All right, so let's do another example. CH3, CH, we'll draw a CH3 up above, and then a CH2, 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 and then a carbon double bond O with a CH3. Okay, so let's IUPAC it, and then let's see if we can common name it. Now, sometimes they don't have a common name, and we'll figure out if this one does, and we'll talk about some of the reasons why or why not. Okay, so we'll do IUPAC first. IUPAC first says longest carbon chain. All right, so longest carbon chain, including the functional group. 1, 2, 3, 4, 5, 6, and 7. It looks like there's 7 carbons in total. All right, so a 7-carbon chain is called heptane. The ending, and add O-N-E. Heptanone is what this molecule is called. Well, what kind of heptanone do I have? All right, well, I need to look at the carbon chain. And when I look at the carbon chain, I'm going to number closest to the end of the functional group. So that would be carbon 1 and carbon 2 and carbon 3 and carbon 4 and carbon 5 and carbon 6 and carbon 7. I could have went straight across, or I could have kinked it up. It doesn't really matter. It gives me 7 no matter what. You would have ended up with the same name. All right, so now that we know that we have a 7-carbon chain, it's a heptanone. Well, it's really a 2-heptanone because that is where my ketone group is located. So 2-heptanone, but we're not yet done. And the reason is because we have not named this piece of the molecule. Right? That's not part of the longest carbon chain. That is a substituent. That substituent is hanging off. That substituent is a methyl group. It's a 1-carbon piece. And that methyl group is hanging off of carbon number 6. So this is a 6-methyl 2-heptanone. Folks, that is the name of that structure according to IUPAC. Now, does it have a common name? Okay, well, this is what you need to do with them. Look at the molecule, circle your ketone group. Right there it is, right there. I see it. If you don't know that's a ketone now, you might as well pack it up, folks. And then to the left, can you name this? Yeah, this is called a methyl. Or to the right. To the left, can you name this one? I hope you can say yes, because we can. You might look at this and you might say, well, wait a minute, this has a little thing hanging off of it. We can't name that. It's too complicated. And I'm going to say, wrong. No, you can, because look at here at the very end. This makes that L function, right? We learned this in Chemistry 251, that carbon, 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 that ending at the very end, that little L that's forming, that's an iso group. Well, what kind of iso is it? Count the number of carbons in total. 1, 2, 3, 4, 5, 6. This is a isohexyl group. So I go through and I put them in alphabetical order. The thing here is that isos don't really get counted. Some people do, some people don't. I don't really care what you do. Again, I'm not taking off if you don't put them in alphabetical order, but typically we do put them in alphabetical order. So I'm going to put isohexyl, then methyl, and then ketone. So isohexyl methyl ketone. There you go, folks. There's the common name for that ketone. All right, let's keep going. Let's keep doing these examples. So here we'll do a ring structure, and that ring has a double bond O. Name it. Okay, so we do this like we do everything else. There is a ring structure, that is the longest carbon chain. That is a cyclo group because it is a ring structure. There's 7 carbons in total. So this is a cyclohexane, the E, and add O-N-E. Cyclohexanone is going to be that name. Does it have a common name? No. That's because how on earth are you going to name the group on the left and the group on the right? There really isn't a true left and a true right because it all circles back around on itself. So no common name is associated there. All right. So we'll keep going on. And let's take a look at CH3 and then a carbon double bond O and then a carbon double bond O. And then a CH3. How do we name that? Well, you're going to look at this and you're going to say, well, wait a minute, I've seen something like this before. This is an anhydride. No, it's not. It's not an anhydride. An anhydride is a carbon double bond O with a oxygen and a carbon double bond O. That is completely different. There is a oxygen in the middle spot that grabs on to the carbons that are involved in the ketone group and glues them together. We do not have that middleman oxygen here. It's not there. So this truly is a ketone and a ketone. So how do we do this? Well, IUPAC rules. Follow it, folks. It tells you everything that you need to know. IUPAC says, what's the longest carbon chain? 1, 2, 3, 4. There's 4 in total. All right, so butane, and then add O-N-E as your ending, butanone. All right, well, that's fine, but the problem is that there's 2 of them. There's not 1. Okay, so that means I'm going to have to go in, and I'm going to have to put a di here. Butanedione. Well, that looks a little weird and silly, doesn't it? I mean, an N and a D side by side together. I mean, that like violates every rule of the English language. So people typically keep the E in this case. Butane and then they'll do dione. Now, I don't know if that looks any better. That's your judgment call to make. But this typically is what we do when we see the N's and the D's like that squished together. We separate them by that E. It looks a little bit better. So butane dione is going to be the name. Now, I don't necessarily need numbers. Once again, if I don't, it's not going to be a problem because my ketone groups cannot be anywhere else. Meaning that if I take this C double bond O that's here and I move it to the left, that is not in the middle of the molecule. It's now at the end, and that makes it an aldehyde. All right. And then the same thing's going to happen here if I move it to this end over on the right, or if I move this ketone over to the right, that is now an aldehyde. It is not a ketone. These are at the very end of the molecule. It's not going to work. It's not going to be a ketone for me. All right. The other possibility that you might say, well, what if they're on the same carbon? Well, that can't happen either. Look at how many bonds that carbon has now. I mean, that's silly too. So double bond O on top, double bond O on the bottom, that's already 4. And then to the left and to the right, that's 5 and 6. So that carbon is way, way, way oversaturated with bonds. That's not going to work for it either. So this is the only possibility for that. But if you're in the groove and kind of following the rules that you set forth for yourself, you probably are going to number them. And it doesn't really matter which end you start at because it gives you the same number no matter what. And those ketones are going to happen at carbon number 4 and at carbon number 2. Or sorry, not 4 and 2, but 3 and 2. So carbon number 2 and carbon number 3. So 2,3 butane dione is probably what you would give me, and that's perfectly okay. Once again, though, the numbers are not required because we know that's the only possibility. All right? Okay, so let's take a look at another one of those just to make sure that we feel okay with that. CH3 carbon double bond O, and then a CH2, then a carbon, then a double bond O, and then a CH3. How do we IUPAC it? And notice I didn't say anything about a common name. Common names really are only for very simplistic ketones, and when we start pulling in 2 ketone groups, that really changes the story. All right? So IUPAC this. All right, that's not a problem, Tracy. I can do this. 1, 2, 3, 4, 5. I can do it in my sleep. So this is a 5-carbon main chain, and that means that this is a pentane. The E and add ONE, but not in this case because there's 2 ketones. So I keep the E just to make it look pretty. I know that there are 2 ketones, so this is a dione for me because the di represents the 2. Well, where are those located? Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. It doesn't matter which way you number in this case because they will get the same numbers no matter what. Normally, we go for the lowest number, but here it's a tie no matter which way we do it. So on carbon 2 and on carbon 4, that is where our own groups are located. So this is a 2,4 pentane dione, right? All right, one more example before we end this video. We've got a CH3 and a CH and a double bond and a CH and a CH2 and a carbon and a double bond O and a CH3. And I want you to IUPAC this. Oh, so here we have a one ketone and we also have a double bond, which is an alkene. That was a Chemistry 251 topic. I told you, foundational, it builds up on itself. So we've got to go through and we have to name this. How do we name it? We do it just like before, like all of the other IUPAC rules. We find the longest carbon chain. Can you believe it? Oh my gosh. So 1, 2, 3, 4, 5, 6. There's 6 in total. So this is a hexane. Well, we're going to have to do some modification, but I'm going to the ending and I'm going to add "one" at the end. It's a hexanone. And the reason is because here's the "one" group. Well, I'm going to number closest to that because I'm naming it as a ketone. Now, again, 2 functional groups. ketone, alkene. If you go back to that ranking chart, you're going to see ketone above an alkene. So that's why I'm naming it as a ketone. If you're ever in doubt, go back to the chart. Always refer back to that ranking chart if you need help to determine how to name them. All right? So hexanone, I'm going to number closest to that end because I'm naming it as a ketone, so I have to. So 1, 2, 3, 4, 5, and 6. So at spot number 2, I have a -one group. But here's the problem. I also have another functional group, and that other functional group is a -ene. So this is not really a hexane, right? This is a hexene. So I'm going to have to go back and I'm going to have to take my little eraser and I'm going to have to get rid of that A in there. And I'm going to have to do a EN because of that. That is the hexane part. But the problem is that I have to give that a number 2. And I can't just write a 4 out here in front and pretend like you know which one's at 4 and which one's at 2. That's not going to work. I have to be very clear cut of where these groups are going to be located. So because of that, well, I'm going to erase the 2 out in front. And I want you to understand that the 4 goes to the ene group. So I write the 4 in front of the hexane. And then what I do, like we've seen before in some of the other nomenclature, is that I will hyphenate this ending, and now I'll put the 2 there, and that 2 spot is going to get the -one, which is the ketone group. So 4-hexane, 2-one. This is the way that I make it very clear about which functional group goes to which carbon. We don't do this very often, but we have been forced to do it in the past. So we split up the endings. We give each ending its own number to make it very, very clear of where this molecule is headed. All right, so 4-hexane, 2-one, and it's perfectly okay to do that type of thing. All right, so that's where this video is going to stop. We're not yet finished with our examples, though. We're going to do some more examples in the next video. We're going to start looking at different types of functional groups that are here, not just with the ketone and a double bond, but what if we have like a ketone and an aldehyde, or some of the other things that we've seen before. We'll go back to the chart. We'll use that chart. We'll talk about, again, how to use it and what it means, and we'll go through and we'll start looking at these other more complicated molecules in the ketone world. All right, so that's what we'll do when we come back.